In this podcast, I'd like to clarify the difference between potential and potential difference. So we saw in the last podcast that the electric potential refers to the potential energy per unit charge at some point in space. This has the symbol V. The potential difference is the difference in potential between 2 points in space. Typically in circuits, this is across some element. This has the symbol delta V and is defined like this. So we said last time that the actual value of the potential is immaterial. Physically, the only thing that's important is the change in the potential. And so this is similar to the gravitational potential energy in mechanics and physics 141. Right? It didn't matter. Only thing that mattered was the change in height. It didn't matter what the actual value of the potential energy was. So unfortunately, in circuits, sometimes as a typesetting issue, some books replace V or delta V by V, right? So this sort of implies that the potential is equal to the change in potential, which isn't the case, right? It's just this is sort of a shortcut that books use. This V here really implies a change in potential, which is the change in potential between 2 points. So you just have to be careful and pay attention to the situations. But let's try and clarify the difference between potential and potential difference. So imagine we have a situation as follows. A couple of resistors, we have 3 points in between all the resistors, and we define the potential at A to be 20 volts, the potential at B to be 12 volts, and the potential at C to be 2 volts. Right? This implies that there's a potential difference between A and B is 8 volts, and the potential difference between B and C is 10 volts. So if we talk about going down, we only want to talk about the change in potential or the potential difference. If we go downward, we go from A to B to C, we can talk about, well, what's the change in potential going from A to B, right? And so that's just going to be the potential at B minus the potential at A. In this case, that's going to be 12 volts minus 20 volts or minus 8 volts. So the change in potential going from A to B is minus 8 volts, which says the potential at B is 8 volts lower than the potential at A, right? Which certainly is the case. 12 volts is 8 volts lower than 20. We can do the same thing going from B to C. The change in potential going from B to C is the potential at C minus the potential at B. The change in potential in this case is going to be 2 volts minus 12 volts, or the change in potential is going to be minus 10 volts. So the change in potential going from B to C is minus 10 volts, or point C, the potential at point C is 10 volts lower than point B. Now we can move upward, right? We can go from point C to point B to point A, and in this case sort of everything is reversed. We can talk about the change in potential going from C to B, in which case that's going to be the potential at B minus the potential at C. That would be 12 volts minus 10 volts, or the change in potential is plus 10 volts. Right? Or what that means is the potential at B is 10 volts higher than the potential at C. We can do the same thing going from A to B, and we see the change in potential from going from B to A is plus 8 volts, which means the potential at A is 8 volts higher than the potential at B. So now, if we know the potentials, we can find the potential difference. Now let's imagine that we know the potential difference. So let's say the change in potential going from A to B is minus 8 volts, and the change in potential going from B to C is minus 10 volts. Okay, in the same situation as before. Now we could define the potential at all those points and say, hey, the potential at A is 20, which means the potential at B, which is 8 volts lower, is going to be 12 volts, and the potential at C, which is 10 volts lower than B, is going to be 2 volts. That would be a perfectly legitimate way to describe the potential. But it's also possible to have the potential at A be 18 volts, right? Then what we know is the potential difference, or the potential at B is 8 volts less than A, so then the potential at B would have to be 10 volts, and the potential at C would have to be 0 volts. And again, we could define it some other way. The potential at these points could be, A could be 11 volts, then B would be 3 volts, and then C would be minus 7 volts. So B is 8 volts lower than A, and C is 10 volts lower than B. And so the main point here is that there's a lot of solutions for the potential for one change in potential between the 2 points. So now let's talk about how this can help us with circuits and talk about current and polarity. So typically it's helpful to include which side of an element is at a higher potential than the other side. So we're talking about resistive materials. Current typically flows from higher potential to lower potential, and so we indicate the higher potential with a plus and the lower potential with a minus. So if the current is going from right to left in this resistor, then that means this potential on the right side is higher than the potential at the left side. If the current is going from right to left, then that means the potential on the left side is higher than the potential on the right side. Okay. Now batteries are designed to have one side at a higher potential, and so this symbol of a battery, or the long edge, is the high potential and the small edge represents the low potential. So you design it so that the edge with the long side is always at a higher potential compared to the low side. And it turns out that in batteries, current can flow either direction. So you can have current flowing to the right and the high sides on the left, or you can have current going to the left and the high sides on the right. The situation will dictate which way it goes, but you can't know just looking at the battery, which is opposite from the resistor, where if you know the current's going to the right, you know the polarity across the resistor. That ends this podcast.